Hi there and welcome to Mr. T's Maths. In this video I'll be showing you how to differentiate polynomials. First of all, let's clarify what differentiation is. Differentiation is the method of calculating the gradient. It can be applied to functions of the form y equals kx to the power of n, where k is a constant and x is a real number. Now, we refer to this as the function, as I said before. Okay, and when we perform this process of differentiation, we end up with the gradient function, or the derivative of the function. Okay, the notation used for the gradient function or derivative is dy dx. It looks like a fraction, but it's not a fraction, it's just a symbol. Okay, so dy dx is equal to, now let's see, how do we differentiate? Well, a function in this form is differentiated by multiplying by the power. So we multiply the coefficient by the power. That leaves us with nk, and then we subtract 1 from the power. And this is basically your formula, if you want to call it as such, for dy dx. Always when your function is in this form. You will see that there will be cases where you will have to first rearrange the function in order to be able to differentiate it. Okay, I have prepared some examples to do together. Alright, so here we have the function y equals 2x. First of all, let's clarify that the power of x is 1. So in this case, dy dx is equal to 1 times the 2, which is 2, and we subtract 1 from the power, which leaves us with 0. But that's the same, sorry for that, that's the same as, well, 1. So 2 times 1 equals 2. Okay, so as you can observe, when we differentiate a term that has x raised to the power of 1, then x disappears. So the derivative function of 2x is just a constant. Okay, let's move on. In this case, dy dx is, remember, you multiply by the power, 20, you take away 1 from the power, to the power of 9. Now, dy dx, in this case, is 4 times 2, which leaves us with 8, and we take away 1 from the power, x to the power of 3. Please feel free to pause the video at any point and actually try these on your own before you actually look at the answers. In this case, we can observe that the power is negative. Okay, so minus 1 times the coefficient. There is no coefficient here, but the coefficient is actually 1, it's not 0. Be careful with that. So minus 1 times 1 is minus 1. We don't need to put it. X to the power of minus 1 is minus 2. Okay, and we can leave it in this form. Alright, dy dx is equal to, here again, minus 3 times 1 is minus 3. X to the power of minus 3 take away 1, minus 4. And in this example, we can observe that we don't really know how to differentiate square root of x. However, we have learned a way of rewriting square roots, and that is the same as x to the power of 1 over 2. Which means that now, yes, now this is in the form k times x to the power of n. So we can actually differentiate it. Dy dx equals half x Now half minus 1 is negative half, and that's the answer. Good. Having done this, let's see how we can differentiate polynomials. Well, differentiating polynomials is straightforward. We differentiate them by differentiating each term individually. Okay, so dy dx equals to the derivative of x squared, which is 2x, plus the derivative of x, which is 1. Okay, let's have a go at the next one. Dy dx in this case equals to the derivative of x squared, 2x, plus derivative of 2x, which is 2, plus the derivative of 1. Okay, 1, you have to treat 1 as 1x to the power of 0, right? So 0 times 1 is 0. That's why the derivative of this will be 0. So we don't need to write that there at the end. Next example, dy dx equals derivative of x to the power of 4, which is 4x cubed, plus derivative of x cubed, which is 3x squared, derivative of x squared, 2x, plus the derivative of x, 1, plus, well, 1 again, the same case, is the same as 1x to the power of 0. So 0 times, oh, I can't. Alright, why don't you let me do that? Okay, so 1x to the power of 0. When we multiply x by 0 by 1, it's 0. So that's why this term, that term here disappears. Now, last example, dy dx equals to derivative of that term, which is minus 6x to the power of, well, minus 2 take away 1 is minus 3. Now, be careful here. This is already a minus 2. And now we multiply minus 2 by a negative power, which will give us a positive answer. So positive 2x to the minus 2 plus 0, which we don't need to write. Okay, that is equal to 0. Okay, and that's how we differentiate polynomials. I wanted to go over some examples where the function involves brackets. In this case, we have to first expand the brackets. So let's go ahead and do that. X times x equals x squared plus x times 3, which is 3x. Now we can differentiate it. So dy dx is equal to 2x plus 3. Okay, so when you have expressions involving brackets, make sure you expand the brackets first. So here 2x times x equals 2x squared plus 2x times 5 equals 10x plus 1 times x is x plus 5. Now we can simplify this further. That's the same as 2x squared plus 11x plus 5, and we can differentiate the function because it's in the form kx to the power of n. It's a polynomial. Okay, so let's do it. Dy over dx equals 4x to the power of 1 plus the derivative of 11x, which is 11, and the derivative of 5 will be 0, so we don't need to add that. And the last example, we can see that there are some fractions here. We don't know, again, we don't know how to differentiate fractions, but we have learned some laws of indices. I'll write it here. I'll remind you that x to the negative n equals to 1 over x to the power of n. So we can apply this law of indices yeah, to rewrite this function. So that's the same as x to the minus 1 minus x to the negative 2 plus pi. So now dy dx can be easily found. That's the same, that's minus 1 times 1, which is negative x to the minus 2 plus 2x to the minus 3. Be careful, there is a plus there because we have minus times minus is positive. And then plus 0. Pi is just a constant. It's a number, so the derivative of a number, the derivative of a constant is 0. So that's our final answer. Okay, I hope you found this video useful, and I hope now you are feeling confident and you do know how to differentiate polynomials. Thanks for watching it, and see you in the next one. Bye bye.